Hello everybody. So last video we talked about the fundamental theorem of calculus and its second part. Okay, so the fundamental theorem of calculus. And we use it to apply and to evaluate definite integrals exactly. Now, one great usage of a definite integral is found in the mean value theorem, and not the mean value theorem that we have talked about for derivatives, but turns out there is a mean value theorem for integrals as well. There's a mean value theorem for integrals. Okay, there's also a mean value theorem for integrals. And what it says basically is that if you have a function that's continuous between A and B, okay, then A and B, okay, then there is a number C, okay, kind of like the mean value theorem. There is a number C such that the definite integral from A to B, from B to A, B is to the right, from B to A of f of x dx, okay, it's our function f, equals f of c times b minus a. And what that basically means is that if you're given a region that I colored in red, that means there's a value c, okay, there's a value, x value c, inside this interval such that I'll just guess is over here, the value c, such that the rectangle this is the area of this blue rectangle. So this is f of c units tall and b minus a units wide. But the area of this rectangle is equal to the area of this region. So that's basically the mean value theorem for integrals. Okay? And what this is useful for is to help us with the concept of average value. The average value function. So let me just rewrite the mean value theorem for integrals. So for every continuous interval from A to B, there's a number c such that the definite integral from B to A of f of x dx equals f of c times b minus a. Okay, it's the mean value theorem for integrals. This f of c is called the average value of a function. Okay, and it has a lot of practical purposes as well. Okay, it does have a lot of practical purposes as well. Okay, and it tells you where most of the points on an interval lie, if it lies around a specific region. Okay, so this average value is quite useful. Okay, and if we were to solve for f of c, you would get f of c, your average value, equals 1 over b minus a times the definite integral from b to a of f of x dx. This over here is the average value, how you find the average value of a function. Okay, let's apply it. Okay, let's apply this average value of a function. Okay, so what do we do over here? Okay, how would we find the average value of the function of, let's do it, I like trig functions. So f of x equals cosine of x from 0 to pi over 2. Okay, so what's the average value of this function? So you would just simply plug it into this formula. Okay, so you get average value equals 1 over pi over 2 minus 0 times the integral from pi over 2 to 0 of cosine of x dx. So this would just be 1 over pi over 2. That's 2 over pi. 2 over pi times 0 to pi over 2 of cosine x dx. So if we evaluate this integral, we get 2 over pi times sine of x. And we just have to evaluate it from pi over 2 to 0. And using the first fundamental theorem, we evaluate this antiderivative at pi over 2, then subtract the antiderivative evaluated at our bottom limit, 0. Sine of 0 is 0, sine of pi over 2 is 1. So we have 1 minus 0 is 1. So we get 2 over pi. So 2 over pi is approximately over here. Okay, so this is the average value of our function. Okay, and it kind of makes sense since the majority of the interval is well above the halfway mark. Okay, if we were to find this at 0.5, the majority of this interval is above 0.5. So it makes sense for this average value to be above makes sense for this average value to be above 0.5. Okay, it's basically it for average value. Average value, it does usually appear on the AP exam. Okay, it sometimes appears on the AP exam. This is an important formula to know and is very useful for many of the applied problems. Thanks for watching. If you have any questions, please comment below. Thank you.